Well, after looking at the past year exam paper question August 2014 question for part B, let's move on to the last part of this question, which is question for part C. Refers to the circuit shown in figure 4.3 below. Suggest the network theorems that you would use to analyze the circuit. Now remember, this time I have two energy sources, one from here and one from here. Hence, determine the currents I1 flowing through here, I2 flowing through here, this branch, and I3 flowing in this branch, right? So this is the requirement for part C of this question. Let's see how we solve this. Well, to answer this question, we can notice that this is a current source. So the current source basically defines I3, right? Whereas we can apply Kirchhoff voltage law to use superimposition to calculate I2, I1. So to start with, I will solve this first, right? Since this is a current source, I3 must be the same as this. Therefore, I start with saying that I3, the branch current, must be the same as this, which is 200 0 degrees milliamp or 0.2 angle 0 amps. Okay, so that's the first answer. Now, applying Kirchhoff voltage law, right? This is Kirchhoff current law. These two must be the same. Applying Kirchhoff voltage law, I will have E is equals to I1 multiplied by Z1 plus I2 multiplied by Z2. Okay, that means 20, the angle of 0 must be equals to I1 multiplied by 100 angle of minus 90 degree plus I2 multiplied by 200 angle of 90 degrees. Okay, so I have an equation here. I also know I3, right? However, we also know that at this point, using Kirchhoff currents law, I1 comes in, I3 comes in, but I2 goes out. In other words, I1 plus I3 must be equals to I2. Okay, so we substitute equation 2 into equation 1. That gives me 20, the angle of 0 degree equals to I1 100 angle minus 90 degrees plus I2, I replace it with this, so I1 plus I3 multiplied by 200 and an angle of 90 degrees. Okay, from here, since I have I1 and I know I3, so I just rearrange I1. I1 100 angle of minus 90 degree plus 200 angle of 90 degrees, right? Because I1 is here, I1 is here. Maybe I just leave here. Will be equals to, this one is I3. I3 I know it's here, so I just substitute I3 as 0.2 angle 0 degrees multiplied by 290 degrees. Right, therefore I get A1 I have these two. Now I need to change this to rectangular and then add them up again. But because they are minus 90 degrees, so it's quite straightforward. So I will have I1. Let's all look at rectangular. Now rectangular is 20. Now here is J100 minus J100. Right, this one is minus J100 plus J200 plus 40 angle 90 degree. Now angle 90 degree is just J. Angle 90 degree is J. Right, so rearrange the formula. I will get I1 is just 20 minus J40 divided by J100. Need to convert this to polar form. So I get 44.721 at an angle of minus 63.43 degrees divided by 100 angle of 90 degrees. So that will give me 0.447 angle of minus 153 degrees ampere for I2. Oh, sorry, for I1. From there, I can calculate I2 since I know I2 is I1 plus I3, right? So I2 is I1 plus I3. Since I know I1 now is 0.447 angle minus 153 degrees plus 0.2 angle of 0 degrees. Again, convert this to polar form. There will be minus 0.4 minus J0.2 plus 0.2. That's equals to minus 0.2 minus G0.2. That gives me 0.283 at an angle of minus 135 degree ampere. Alright, so I have calculated I3, I1, and I2. Right, so that's all for this question, August 2014 exam paper question 4.